Okay, so again, let's continue our discussion under the topic statical stability of floating bodies. Let's try to solve the first example or illustrative problem here. Okay, a plastic cube of side L, sorry, nantok now, and specific gravity equal to 0.82 is placed vertically in water. Is the cube stable? So, yung plastic cube, try mong ilagay sa tubig, would it float in a stable position or manner or unstable siya? So, pag unstable siya, so it would roll siya dun sa tubig. So again, review lang natin, a floating body is stable if the metacenter is higher than the center of gravity, and it is unstable if the metacenter is lower than the center of gravity, or as I've said sa previous video, compare lang natin yung MBO and GBO. So MBO, if MBO is greater than GBO, the floating body is or I should say stable. Sorry. So if MBO is greater than GBO, the floating body is stable. If MBO is less than GBO, then the floating body is unstable. So our indicator is the location of M, or the distance between the metacenter and the center of buoyancy. Let's try to illustrate the problem. So ito yung cube. So each side is L. Ano? So yan. So since it is a floating body, that means that the buoyant force is equal to the weight. So why do we need to apply this principle? Because we need to solve for the center of buoyancy. So remember, kailangan natin ma-solve yung MBO and GBO and we compare. So we need to know first yung location ng center of buoyancy. Okay, assuming that it floats up in an upright position. Okay, initially, it will float in upright position. Kapag unstable siya, it will try to roll over and over sa water. So, kailangan mo natin solve ang center of buoyancy. So, ano ang center of buoyancy? Yan yung geometric center ng displaced liquid. So, this shaded portion is the displaced liquid. Yung yung centroid niyan would be the center of buoyancy. So, kailangan natin i-solve yung draft. We call this the draft. That is the depth of flotation. So, gaano kalalim or yung nalublob dun sa liquid. So, we call that the draft. Or D-R-A-F-T, draft. Okay, we need to solve for the draft by using the principle of buoyancy. So, equate lang natin yung dalawa, yung buoyant force and the weight, since it is a floating body. And let's try to expand this equation. Let's try to solve each variable in the equation. So, BF is equal to, sa previous topic natin, principle of buoyancy, it's the gamma of the displaced liquid, which is in this case water. Water ba to? Yeah, that's what I thought that's a different kind of liquid. So water siya. So gamma of water times the displaced volume. Expanding this further, since we are solving for the draft, we need to express the VD or displaced volume in terms of the draft. So gamma of water times L, ito, times L, the perpendicular dun sa paper or sa screen. If you're watching, of course you are watching this on the screen. Ano? Okay, or if you have printed your module then in your paper. So L, ito, times yung L na perpendicular sa screen, times D, ito. That's a displaced volume. So BF is equal to gamma of water times L squared times D. So that was the buoyant force. Then, solving for the weight of the plastic, given naman yung specific gravity ng plastic. So weight of plastic is equal to gamma of plastic times the volume of plastic, which is the entire volume. No, yeah, yeah. And then weight is equal to gamma of water times specific gravity ng plastic times volume. Then weight is equal to gamma of water. Specific gravity of plastic is 0.82 given dun sa problem. And then volume ng cube, of course, is if each side, if one side is L, then it would be L cube. Then equate the two, then cancel itong gamma of water, and then we can solve for D in terms of L. Ayan. So cross multiply lang natin. So for D, that's 0.82 of L. Okay, so that is the graph. Ito. So we can now solve for GBO by inspection. So GBO, distance between the center of gravity and the center of buoyancy. So basically, since yung cube ay hindi naman loaded, wala siyang karga dyan sa tuktok. No? So the center of gravity then is the center mismo ng body. So that is if one side is L, then the center is L over 2. Okay, ito. And then ito, BO. So if center naman yung BO is equal to if this is the graph, D over 2. Ayan. So D over 2 yan. Okay, so by inspection, we can solve for GBO. So GBO is equal to L over 2 and minus D over 2. Now, GBO is equal to 0.09 L. Okay, 0.09 L. Okay, and then solve natin yung MBO using the general formula, which is equal, MBO is equal to I over VD. So, that's L times L cubed over 12. That's ito. Cross section yan. Yung I niyan is the eye of the cut sections. If this is our water line or liquid surface, ayan, yung na-cut niya dyan, yan yung solve natin ng I. So, which is equal to L times L cubed over 12 times displaced volume is equal to, so D times L perpendicular to the screen. Ayan. D is equal to 0.82 of L as we have solved a while ago. So MBO is equal to 0.102. Now we have the two values already, GBO and MBO. Okay, so compare. So MBO is greater than GBO, therefore the floating plastic cube is stable siya. Now, we can also solve for MBO using the derived formula for rectangular section. No? So, MBO is equal to B squared over 12D times the quantity 1 plus tangent squared theta over 2. So, since wala naman siyang angle of tilt, hindi naman siya nag-tilt. Hindi naman sinabi sa problem na nag-tilt siya. So, basically, 0 ito. Ayan. So, MBO is equal to L squared over 12D. Ayan. So, tangent 0 is actually 0. So, 0 divided by 0 ba to? Tama. Ayan. So, MBO is equal to 0.102L. So, MBO is greater than GBO. Therefore, the floating body or the floating plastic cube is stable. Ayan. So, compare lang natin yung MBO and GBO. Then, we can arrive at the conclusion, okay, whether if the body is stable or not. So, that's it. That's problem number 1. So, the next problem would be solved on the next video. Okay.